Hi guys, Mr. Thompson here with a video math lesson on scientific notation. Scientific notation is basically just a particular way to write numbers. It works particularly well for very large or very small numbers, and basically just makes them easier to sort of read quickly and sometimes to use them in calculations and to see how big or small they are and so on and so forth. So this is just a quick how to put numbers into scientific notation. Scientific notation always comes in a particular form, okay, with a number represented here by an A times 10 to a power, okay, or to an index, to an exponent, right, raised to a power. Okay, this A is always between 1 and 10. Okay, it can be equal to 1. So greater than or equal to 1, and less than 10. Cannot actually be less than 10. Okay? Sorry, must actually be less than 10. Cannot be equal to 10. Okay? The 10 here is always a 10. Okay? There's just always a 10 there in scientific notation. Okay? And then we have this power, which always will be an integer. Okay? And if you're only just learning powers and indices, you might be surprised that there can be other kinds of exponents, other kinds of powers. Yes, you can have things that aren't integers, but in scientific notation you will always get an integer here. Okay, so what that means is just a whole number, right? 1, 2, 6, 8, 36, negative 50, right? Those are integers, okay? And so these numbers in scientific notation always will be numbers. So let's look at an example. Here we've got 2,473,000. Okay, pretty big number. So we're going to put this in scientific notation. First thing I do is look for my first non-zero digit. Okay, in this case it's just the first digit. It's the first number on here and it's a 2. Okay, it's not 0, and it's the first one that's not a 0. So we're going to just put that down. I'm going to write my scientific notation right here. I put the first non-zero digit and I follow it immediately with a decimal point. Okay. Then I write all the rest of the digits that follow it until the last non-zero digit. Okay. This is the last digit here that is not a 0. The rest of these are all zeros. So I put all the numbers on here until I get to that last non-zero digit. So from the first to the last of all the non-zero digits. Okay, and then I'm going to have my times 10. Okay, and going back to this, you'll notice that number here is between 1 and 10, right? 2.473 is between 1 and 10, right? Times 10 to a power, and the question is, what do we put here for the power? To figure out what we put there, we need to ask ourselves, how many places did we move the decimal point? Okay, so the decimal point was over here, right? It's just implied. You don't have to write it when there's no more decimal places, but it would have been here if we had it, and so we just count how many places it moved, right? So it starts 1, 2, 3, 4, 5, 6, right? And that's the number we put here as our exponent. Okay. And that's all there is to it. This is now the number in scientific notation. Okay, let's look at another example. Okay, those two things, of course, are equal. Okay, another example. Write the following in scientific notation. Okay, the number is 0.0000000477601. Okay, very small number this time. Much smaller than 0. Much smaller than 1. Right, close to 0. So we're going to do the same process as we did before. Here's our first non-zero digit. Okay, it's a 4. There's a bunch of other zeros in front of it, but the first non-zero one is this 4. Okay, so we write 4 with a decimal point after it, and then all the following until we get to the last non-zero digit. Okay, 1 is the last non-zero digit. So, and then we get our times 10. And we need to put a power here. So again, we ask ourselves, how many places did we move the decimal point? All right. Well, it started off here, and it moved all the way to after the 4. Right. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay? Now, unlike before, we moved our decimal point this time to the right. Last time we moved it to the left, right? So last time we had a positive exponent in our scientific notation. This time, because we moved it the other way, we're going to have a negative number in our exponent here. Okay, whenever we move it to the right, we get a negative exponent. An easy way to think about that is whenever you have really large numbers, like that 2 million number, we have a positive exponent, and whenever you have a really small number, a very small number, we get a negative exponent. Okay? So let's look at another kind of problem you'll see. You'll be given scientific notation like these numbers here, and you'll be asked to write it in standard notation or decimal form. Okay, and in these ways, it's pretty easy to do it this way. Here we have 8.40003, and we're just going to write all those digits out, all those numbers out in the same order, and we move the decimal place this many times, right? So it was here in front of the 8, was there, and we're going to move it 12 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we'll have a new decimal point there. Right? I'll fill in all those blank spaces with zeros and get rid of my purple line, add some commas, and there we have 4,400,000,000,000 and 30 million. All right? And you can start to see when you do this some of the benefits of writing it in scientific notation. It can be a little bit simpler. This one here we have a very small number, right? 3.002 times 10 to the negative 6th. If you think about what we're going to do here, we're multiplying by 10 to the negative 6th, which is equal to, 10 to the negative 6 is equal to 1 over a million, 1/1,000,000th. So in essence, we're multiplying by 1/1,000,000th, or in other words, dividing by a million. When you divide by a million, you move the decimal place to the left 6 times, right? So we're going to move it that way, right, over there. So I'm going to put my digits from this number down here with a little space to the left to put some zeros or whatever I need. I'm going to move the decimal place 6 times to the left, right? So starting here, right, I'm going to go 1, there's my decimal point, 1, 2, 3, 4, 5, 6, okay, and put a new decimal point. Again, fill in the spaces with zeros, as well as putting a 0 out here in front, okay, erase my purple line and put a nice green decimal point. Okay, so again, large numbers, positive exponent, small numbers, negative exponent for the scientific notation, right? That's all there is to it. Best of luck, and see you next time.